All right, this problem we're asked to figure out what percent of men will weigh more than 240 pounds, given that the mean is 172, standard deviation is 29. They do not tell us that the weights are normally distributed, and we have this key phrase here, what percent will weigh more, right? So anytime we're talking about the percent that's going to be larger than a certain number, smaller than a certain number, between two given numbers, we have to think of Chebyshev's theorem as a possibility. Now, if we're not told that it's bell-shaped in distribution, we can't use the empirical rule, so Chebyshev's is really our only choice. And then what we have to do is to say, well, if we're going to deal with Chebyshev's theorem, we have to have an interval that's symmetric around the mean. So even though this next step that I'm about to do isn't necessary entirely, it is necessary in theory, but of course we could get around it by using some shortcut. But let's work it out anyways, the way we're supposed to, which is to say that if we're going to deal with Chebyshev's theorem, we have to have a mean in the middle, and we'd have to have an interval around it. That's how Chebyshev's theorem works. It has a symmetric interval surrounding the mean. The only number we're given to work with is 240, really. So that would have to be a number at the top end of an interval that would be surrounding the mean, because it's bigger than the mean, right? So if this is 172, the question is how far away is 240? So if we did 240 minus 172, we should get 68, and we do, right? So in other words, to get from here to here, you have to add 68. So the mean of 172 is 68 points below 240. Now, in order to get an interval that's symmetric around the mean, we have to have a number down here that's also 68 away from the mean. But this case it would be minus 68. So if you do 172 and subtract off 68, you're going to get 104. And that 104 is the lower value for your interval. So now we have an interval that's symmetric around the mean. From 104 to 240 is an interval that surrounds 172 in a symmetric way. In other words, both numbers in the interval are 68 away from the mean. Now from there, the next step would be, if you're using Chebyshev's theorem, to find k. Remember, k will be the upper limit minus the mean over the standard deviation. So upper limit is 240 minus the mean of 172. We just said that that would be 68, right? Just figure that out, and then divide by the standard deviation, which is 29. So if we take 68 and divide it by 29, we get the value 2.3448 ... right? Now to figure out what percent is going to be inside the interval, which is the only thing Chebyshev's theorem can give us, we're going to use the phrase at least, and then the formula 1 minus 1 over k squared times 100%. So in other words, I need to plug this number in for k. So we're going to do 1 minus 1 divided by 2.34482756, right? Squared. And when I do that, I get the answer 0.8181 ... Of course, times 100%, we get basically 81.8%, right? So at least this percent is inside the interval. Now let's think about it. That's what's inside the interval at minimum. Nothing else can be outside of the interval. I'm sorry, nothing less can be inside the interval. So we can't have anything less than 81.8%. In other words, could it be that there's only 70% in the interval? No, because there's going to be at least 81.8%, or basically 82%, right? So what you want to do next is simply do this. You want to say, well, that's what's inside the interval. What would be outside possibly then? What could possibly be outside the interval? Well, 1 minus the answer we just found, right? So that would give you 0.182, or 18.2% is outside. And that would be the most that you could have outside. So at most, 18.2%. Because if it's at least 81.8%, or let's just say if it's at least 82% in here, then it means at most 18% could be outside. And of course, that would include the amount that's more than 240. So all of it could be here. Don't make the mistake of assuming that it has to be half of it here, half of it there. Remember, for Chebyshev's theorem, there's no symmetry for the actual distribution. So we don't know for sure that the distribution is symmetric. It could be bell-shaped for all we know, or it could be very skewed so that all the extra stuff is here. It could be skewed this way so that all the extra stuff is here. It could be all contained within here, right? It could be 100% because it says at least 82% is inside the interval, right? At least. That means it could be as high as 100% in the interval, which means there would be nothing out here, right? So the maximum that can be out here, though, is 18.2%, because we know that inside here holds no less than 82%. So that's the key. So either way, if you wanted to use a shortcut to solve this problem, you could very simply take the 240, plug it in here, do your calculation for k, plug that into here, get your answer, and once you have the answer, you just do 100% minus this percent, and that's the answer for your problem. So 100% minus 81.8% would have given us 18.2%, and you tack the word at most in front of it. So remember, when you're looking for values outside the interval, it's at most. When you're talking about what's inside the interval, you use the phrase at least. Outside at most, inside at least.